So we are going to see some special type of receivers. It is called as Hartley image reject receiver. So this receiver is going to be it is going to use the same architecture as before. And you see here from the lower arm, whatever you get the signal from the lower arm, it is going to be Hilbert transform of that from the upper arm. So effectively they say the phase shift between upper arm and lower arm is going to be 90 degrees. So this receiver will produce the output and its Hilbert transform if the cutoff frequency is more than omega L naught, or it will produce signal and negative of Hilbert transform, the cutoff frequency is less than omega L naught. So this is very simple. So you get the signal and its Hilbert transform. If the cutoff frequency is very high, you will get the signal and its negative Hilbert transform. The cutoff frequency is going to be very less. And if you add this I of t and q of t, you will get back your original signal. But what is the guarantee that I of t and q of t is free from image? That is, there is no guarantee. We still assume that the sum of I of t and q of t still may contain an image signal. So we have to see what can be done for the architecture to eliminate the image component from the in-phase component and quadrature phase component. However, since the Hilbert transform of Hilbert transform negates the signal, so when you perform Hilbert transform twice, the transform has no meaning, so it will negate the signal. So to applying Hilbert transform twice will negate your signal. Applying Hilbert transform 4 times will get back your original signal. Okay, so if you shift I of t or q of t by another 90 degree before adding them, the image will be removed. So that is one additional phase shift we are going to use. See here. So this architecture is, this is a conventional architecture where we are going to multiply with phase shifted values of local oscillator. After that, you ensure that you are going to select only your appropriate channel and you do one more phase shift. So the in-phase signal will be coming directly to your output, but the quadrature phase will be shifted by 90 and that output you will be getting in the upper arm. So when you add both, the image in phase and image in quadrature phase are phase shifted by 90 and they will get cancelled while the signal will get added. So this is going to form the basic rule for image reject receiver using Hartley architecture. So low pass filters, I'm going to use them to remove unwanted high frequency components. So to understand the operation of Hartley architecture, we assume a low side injection, apply a phase shift of 90 degree. So I'm going to apply 90 degree phase shift only to the Q arm, not to the I arm. So applying 90 degree phase shift, it is going to produce Hilbert transform. So we know that when you shift by 90 degrees, it is equivalent to multiplying the signal by 2j into signum of omega. So the quadrature signal is multiplied by 2j signum of omega, but whereas the in-phase signal will be having, as it is, in-phase signal will be multiplied by nothing, multiplied by unity, and when these two are going to add, it is going to cancel out the image. So you can see here the spectra at point B and C. B is going to be, see here, B is going to be before the phase shifter and C is going to be after the phase shifter. You can see here. So this is the output at B. So Q, the signal, and at IF, you can see the two components are present. Two odd components are present, and after your 90 degree phase shifter, you can see it is, this one is shifted by 90 and this one is also shifted by 90. So you can see it is rotated by 90 degrees in the anti-clockwise direction. So in summary, you can clearly say that Hartley architecture first takes a negative Hilbert transform of the signal and Hilbert transform of the image. So since we are adding a phase shifter in the quadrature arm, I am going to take the Hilbert transform of the Q part. So subsequently, when I am going to add that, it is going to cancel out the image. So when the signal is multiplied by j signum of omega into minus j signum of omega, you get +1. When the image is multiplied by 2 times of the negative of signal, it becomes -1. That's why we say signal is getting added, image is getting subtracted, or I can say image is getting completely cancelled out. Okay. So this behavior of Hartley architecture can also be expressed